Good morning. This is one of our core papers, Thermal and Statistical Physics. So, in that paper, I'll be teaching you Module 1, which is about equation of state for gases. So, this is the first class on the topic equation of state for gases that comes under Module 1 of your paper, Thermal and Statistical Physics. So, before beginning, let us recollect some of the basics about gases. We know that the ideal gas equation is given by PV is equal to nRT. Okay, where P is the pressure, V is the volume, N is the number of moles present in the substance, R is the universal gas constant, and T is the temperature. Now, any gas that obeys this ideal gas equation under all conditions of temperature and pressure is called an ideal gas. Whereas gases which do not obey this equation under all conditions of temperature and pressure is called a real gas. Now let us see the definition for equation of state. Equation of state is nothing but a relation between state variables. State variables means we know that in order to describe a system we may use various variables to describe the state of existence of the system like temperature, pressure, volume, internal energy, like that. So the relation or equations connecting these state variables that describe the state of existence of the system is called by the name equation of state. So, equation of state is a thermodynamic equation that describes the state of matter under given set of physical conditions. It also gives us the relationship between the state functions associated with the matter, just like that I have told earlier, like temperature, pressure, volume, or internal energy. They are also useful in describing the properties of fluids, mixtures of fluids, solids, and even the interior of stars. They are also used for analyzing the data related to volumetric data, thermophysical data, and so on. And they can also be applied over a wide range of temperature and pressure, as well as to mixture of gases ranging from very light gases and even to heavy liquids. So that's all about the definition for equation of state and its uses. Now let us see some of the major equations of state. Okay, now this temperature, the parameters or the state variables like temperature, volume, pressure, etc. are not independent quantities. Instead, they are related by this particular general form, that is function of PVT equal to 0. P is the absolute pressure, V is the volume, T is the absolute temperature. So the gases in almost all the gases will follow this equation of state. So this is actually the general expression for equation of state for a gas. So here we know these are some of the our main quantities are described here. As I already said, it is P is the absolute pressure, V is the volume, T is the absolute temperature, and so on. Actually, absolute temperature refers to Kelvin scale, with 0 being absolute 0. Now, one of the most important equation of state is the van der Waals equation of state. Now, we know that ideal gas law, that is PV equal to nRT, that actually treats the gas molecules as point masses or point particles with elastic collision, but actually these gas molecules are not point masses. So this ideal gas law has to be modified. So for that, a scientist named van der Waals in 1873 modified the ideal gas equation, that is PV equal to nRT, into a particular form like this. Okay, he actually included, or he actually considered molecular size as well as molecular interaction forces. Incorporating these two ideas, that is idea of molecular size and molecular interaction forces, in the earlier ideal gas equation, he modified that earlier ideal gas equation PV equal to nRT to this particular form, that is P plus A by V square, V minus B equal to RT. And these variables have their usual meaning, that is P is the pressure, A is the volume, R is the universal gas constant, T is the absolute temperature. Here you can notice two constants, that is A and B. So A and B are nothing but positive valued constants which are characteristics of the individual gas. Okay. So here A is given by this expression, that is A is equal to 3 PCVC square. PC is actually critical pressure, VC is a critical volume, whereas the constant B is given by VC by 3. So this A, the constant, it's a positive valued constant, or it actually provides a correction data for intermolecular forces, whereas the constant B, it is also a positive value and it gives a correction for finite molecular size. Okay. And its value is the volume of 1 mole of atoms or molecules. So A and B are positive valued constants and they are actually the corrections included. A actually stands for the correction for internal intermolecular forces, whereas B actually stands for the correction for molecular size. So this Van der Waals equation will approach the ideal gas law PV equal to nRT as the values of these constants, that is A and B, approach 0. Now another equation of state is the Redlich-Kwong equation of state. It is a cubic equation based on Van der Waals equation and it is applicable to mixtures, and it's that equation is given like this. Then another equation is Soe-Redlich-Kwong equation, and it is actually uh, a modification brought to the above equation, and it actually predicts the phase behavior of mixtures in critical region, or it actually describes both liquid and vapor phase behavior. It is given by this particular expression. So you need to study only these two paragraph and the expressions. Then the final one is the Penn-Robinson equation. It is enough to study one or two sentences of this equation and just write the expression. Okay, no need to elaborate the writing part. Okay, so it is developed in 1976 to handle both liquid and vapor properties near equilibrium conditions, and it is given by this expression. Rho is called the liquid density. So when you are asked to write about equation of state, first of all you have to write the definition for equation of state, its uses, and then write this general expression for equation of state and explain the terms, and after that give one or two examples for some of the major equations of state. One is Van der Waals equation of state. This you have to write fully, because this is the most important or one of the most important equation of state. So there is nothing difficult to study, and after that for these two equations it's enough to write it briefly. Just write one or two sentence about this equation and write the equation, and same as that with Penn-Robinson equation. Okay, but for Van der Waals equation you have to write it fully, because that is one of the most important equation of state. Now these two are expressions for general equation of state and modern cubic equation of state. If you want you can write, otherwise you can skip these two expressions. Okay, these two. Now next another important topic is the how will you distinguish between a real gas and ideal gas. As this is an important question, that is distinguish between real gas and ideal gas. Here I have presented one or few points. Ideal gas obeys all gas laws under all conditions of temperature and pressure, whereas real gas obey gas laws only at low pressure and high temperature. Only at low pressure and high temperature. Now, when comparing with the volume occupied by the gas, the volume occupied by ideal gas molecules is negligible compared to volume occupied by gas, whereas volume occupied by real gas is not negligible compared to volume occupied by the gas. Next is the attractive force. Force of attraction among ideal gas molecules is negligible, whereas force of attraction among real gas molecules is not negligible. That is, they are not negligible at all, temperatures and pressure. Ideal gas has no definite volume, while real gas has a definite volume. Ideal gas has no mass, whereas real gas has mass. Then collision of ideal gas particles is elastic, whereas for real gas it is non-elastic. For ideal gas, pressure is high when compared to real gas. Ideal gas follow the ideal gas equation PV equal to nRT, whereas real gas obey van der Waals equation, that is P plus A by V square, V minus B equal to RT. Ideal gas cannot be liquefied. It's not possible to liquefy ideal gas. Why? Because it has no intermolecular attraction. Whereas real gas can be liquefied because it has intermolecular attraction. Okay. Now, what about the coefficient of thermal expansion alpha? For ideal gas, this alpha depends on temperature and it does not depend on nature of gas. But for as real gas, this alpha is found to vary from, it will be different for different gases, and it depends on nature of gas. So what is ideal gas? It will be the just reverse in the case of real gas. Okay, now what about the coefficient of compressibility beta? For ideal gas, it depends on pressure and it will be the same for all gases, but for us, for real gases, it is found to depend on the nature of gas. So ideal gas law is only an approximation to the actual behavior of gases at high densities, that is at high pressure and low temperature. The behavior of real gases deviate from ideal gas law, that is real gas deviates from ideal gas under which condition? At high pressure and low temperature. Okay, whereas so in general, at sufficiently low pressure or at low densities, all gases behave like ideal gas. So this is one of the most important condition, that is a real gas deviate from ideal gas under which condition? At high pressure and low temperature. So this difference between ideal gas and real gas, it's very important, so you can study that. Now let us see some of the basic laws of gases that we have studied in your lower classes. What is Boyle's law? Here in Boyle's law, gas volume is found to vary inversely with pressure, so PV will be a constant. That is the mathematical expression for Boyle's law. What about Charles' law? There is a linear relationship between volume and temperature, that is V by T will be a constant. Then Dalton's law of partial pressure, it states that pressure of a mixture of gases is equal to the sum of pressure of all of the constituent gases alone. That is P total will be equal to P1 plus P2 plus Pn. So summation over I equal to 1 to n Pi. That is pressure of total pressure of a mixture of gases will be equal to the sum of the pressures of individual gases that constitute the mixture. Next is ideal gas law, the last one. That is Boyle's law and Charles' law was combined uh, into the first statement of ideal gas law. Initially, it was formulated by this particular expression. Where R is a gas constant. Later, the number 267 was revealed that the number should actually be close to not 267 but to about 273.2, and then the Celsius scale was defined for that particular temperature range, that is 0 degrees Celsius 273.15 Kelvin. So taking into account this particular value, this equation was further modified and it became like this. So another simple expression for ideal gas law is PV equal to nRT. Okay, so that's all for today. So just study the definition for equation of state, what are its applications, its uses, then about equation of state. Okay, in the next class we will study about the behavior of gases. Okay, thank you.